Hey guys, so this is the second video on measurements. I'm gonna actually use my pen and work out some math here for us today. So just picking up where we were talking or where we were finishing up on the last video, we'll start right there. So I know that in the last, I guess we'll call them episodes, you saw this practice problem. Just a couple things I want to point out. Obviously, we're looking for density. We want to use the density equation. We know that density is mass over volume, okay? So when I'm pulling things out of a word problem, I want to identify the mass unit, right? So there is the mass unit. Let me grab my pen here. Okay, so there's my mass unit. So this tells me there's the mass, okay? And it says the volume of the sample is 3.1 centimeters cubed. Now, even though it doesn't say the volume is, I know that because I have a cubed unit, all right, that units don't cancel out, okay? So just to point that out, I have what's going on here? My mouse. Ignore that. I have 8.4 grams divided by 3.1 cubic centimeters. And these two units, they're not like terms, so they don't cancel. So 8.4 divided by 3.1 is 2.7, but grams divided by centimeters cubed is not anything else. So I just keep grams per centimeter cubed. So when we said the unit was conserved in the last video, that's what we're talking about. All right, so moving on. The prefixes in the metric system are important, and we use them to do what we call conversions. Now, you use conversions time. Anything 4 quarters in a dollar, 60 minutes in an hour. And what you're actually doing is you are using a ratio to describe how two things are related. Okay, so the fancy definition is right there in front of you in the blue text. But basically, you're using fractions, all right, in order to equate different things. Now, the easiest way to think about this is in terms of quarters and dollars because we use them all the time. But let's look at this slide because this is more relevant to our chemistry discussion. So if you're given a mass like 4.5 kilograms, and we need to use grams for a math problem, or we only have a scale that will do grams, so then we need to do something, we need to convert, okay? So I need to go from kilograms over to grams, and in order to do that, I need to be able to use a fraction that gets me from point A to point B. And so in order to do that, we do something called the factor label method or dimensional analysis. So another name for this is factor label method. So if you're looking online, if you're trying to find, another description of this, you might see it called the factor label method. Same thing as dimensional analysis, but we're going to call it dimensional analysis, all right? So in order to convert from mass 1 to mass 2, I'm going to use fraction math in order to multiply or divide units and get rid of the units I don't want and keep the units I do want. So this is what is really going on here. I have 4.5 kilograms as my starting material. Now, this is a fraction. It's over 1 because anything over 1 is itself. Now, in order to get rid of kilograms, it's on the top of a fraction bar, so I need to put it on the bottom. So I'm going to put it on the bottom. I want to be left with grams, and kilograms can be converted by fraction to grams. I know that there are 1,000 grams in a kilogram. Now, when I look at this, kilogram is on top, kilogram is on bottom, so it cancels. The only unit I'm left with is grams, and then I just plug my regular math operations in. So when I'm multiplying fractions, you multiply the top, so 4.5 times 1,000 equals 4,500. 1 times 1 is 1. Anything divided by 1 is itself, so I just leave it alone. And the only unit I have left is grams. And so that I can say 4.5 kilograms equals 4,500 grams. Now, most often, all right, we don't draw this with parentheses. So I'm going to actually use a backwards arrow here. This is normally how we would write this. We use what we call brackets. So I have 4.5 kilograms. I put kilograms on the bottom of my next bracket. A prefix unit can always go to a base unit with one bracket. 1 kilogram is equal to 1,000 grams. Kilograms cancels, so 4,500 grams. This is the goal, all right? So we're going to put the goal right there, all right? We want to be able to use what we just call brackets in order to convert quantity A to quantity B. So let's try one of those. All right, it says we want to express a mass of 5.712 grams in milligrams, and then also in kilograms. So we're going from grams, all right, and something that we should be able to spot, that is a base unit, okay? I know it's a base unit because if we go back up here, all right, the base unit is just 1. It doesn't have a prefix, all right? And so gram, because it doesn't have a prefix, is a base unit. A base unit to any one prefix is one bracket, all right? It takes one bracket to do that conversion. So milli, I see this. This is a prefix, okay? And I just have to know, right? I have to memorize, I have to learn that milli means 1/1000th. So right now, this tells me that I'm talking about this number in terms of 1/1000th of grams. So in order to do that, all right, just ignore the bottom one. We go 5.712 grams, grams on bottom, milligrams on top. There are 1,000 milligrams in 1 gram. That gives me 5,712 milligrams. Now, if we do the same thing, so now ignore this. This will be the first answer. So we'll solve this part 1. Okay. This is part 2. I still have a prefix, but kilo, all right, is 1,000 of whatever the unit that comes after this. So I still have my base, right? So kilogram, 1,000 grams. If it's kiloliter, it's 1,000 liters. If it's, kilo horses, you have 1,000 horses, right? So whatever kilo goes in front of it is 1,000. So I'm still going base to prefix. So that's still just one bracket. So again, we look at it. 5.712 grams, 1,000 grams in 1 kilogram gives me 0.005712 kilograms. And of course, we could also, if we were good little science students, right, we would write 5.712 times 10 to the negative, right? And we go 1, 2, 3 places. So 3 kilograms. Don't forget the unit, all right? No naked numbers, right? Units are like clothes, so make sure they're covered. Now, something that's worth pointing out here, when I'm going from this larger unit to the smaller unit, all right, and it's just one bracket, I have the large number on top. When I'm going from the smaller unit to the larger unit, right, grams to kilograms, the larger number's on the bottom. That should make sense to us, right? If I have 5 grams, I should have much less than that in kilograms. If I have 5 grams, I should have much more than that in milligrams because milligrams are smaller. When you're setting up your brackets, you would do the bigger unit gets the 1, unless it's a not metric unit, right? So sometimes in things like in English units, you might say like, 1 kilogram is 2.2 pounds. Then it's not a bigger or smaller, that's a definition. But in terms of prefixes, the larger unit gets the 1, the smaller unit gets the number that is equal to 1 of the larger units. Okay, so in this case, 1,000 milligrams equals 1 gram. All right, and anytime you have a bracket, the top has to equal the bottom. So 1,000 milligrams equals a gram. That's true. That's good. If you flipped it, number 1, you're going to get the wrong answer. But number 2, you would know it's wrong because you're saying 1,000 grams is equal to 1 milligram. So you want to make sure that you get your numbers in the right place. All right. Now, I know that this is what it looks like with your fraction bars and all that kind of thing, like you might put in your calculator. But if we're drawing it out by hand, okay, we would just use our brackets. So we would say 5.712 grams. All right, and we, again, just draw the brackets like this. This is called my given unit. Right? It's the thing the problem gave me. Whatever the given unit is, it goes on the bottom. And then I ask myself, how can I convert this given unit into the thing the problem wants? Well, if it's a base unit can go to any prefix, all right? So grams up to milligrams is no problem. That's a one bracket problem. 1 gram has 1,000 milligrams in it. I don't need a calculator for this. I just need to move my decimal. So 5,712 milligrams. Same thing if I'm doing the second part of the problem, right, then in kilograms. So I take my given, 5.712 grams. I draw my first bracket. Whatever my given unit is goes on the bottom because I need to get rid of it. That's not the unit I want to finish with. Since it's on top, I got to put it on the bottom to divide it out. Grams can go to kilograms in one bracket because gram is a base unit. So base unit can go to anything in one step. I know that there are 1,000 grams in a kilogram. So now I'm dividing, right? And again, there's 3 zeros here. I need to move my decimal 3 places to the left. So 0.005712 kilograms. All right. So I draw it with the brackets. If you're putting a calculator, it might have those parentheses. But either way, you get the right answer.